Okay, last time we talked about exponential functions, so we're going to start in on logs. And remember, the inverse of an exponent is a logarithm. So in logarithm form, these both here represent the exact same expression. Turn my pen on. Is log base a of x equals y, and a to the y equals x. Notice that the base, which is the a here and the a here, stay the same, and the x and y switch spots. So in a log, we call the base the little number down that's below. That's called the base. The number in front of the log is called the argument, and the answer is an exponent. Okay, so we've got to keep that in mind, is the answer is the exponent. Okay, now we want to be able to convert from one to the other. A log without a base is understood base 10. So the base stays the same. The exponent becomes what log equals to. The answer becomes the exponent, and the argument becomes that answer. So base stays the same. The 4 and the x minus 1 switch place. The 3 stays the same. The 4 becomes the exponent, and the argument is what an exponent equals to. Now reversing it and going from exponential to logarithmic is I write the word log, the base stays the same, 16 is now the argument, and the exponent is its answer. So E has a special log, it's called natural log, and so the argument equals the x, and then log base 5 of 9 equals 2x minus 1. And then log base 3 of 18 equals x plus 2. So learning to convert from one form to the other is important. Okay, so evaluating without a calculator means that it's going to be a math fact. So we have to have a thought of how to evaluate these. So when I see log base 4 64, what we think about is 4 to some power equals 64. So I think about my powers of 4. 4 times 4 is 16. 16 times 4 is 64. So that took to the power of 3. So when I look at in my denominator, when my base goes into the denominator, I know that I have a negative exponent because remember that makes the reciprocal. So I think about 6 to what power puts me at the bottom. So I'm thinking that's to the second power, so that would be negative 2. And when a number gets smaller, that means I've taken some type of root. Okay, so I'm thinking about 16 to some power became smaller, which is 2. So I think about the powers of 2 to get to 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So that would be the fourth root of 16 is 2. So that means that would be to the 1/4 power. So if you go back to your Algebra 2 days, the denominator in a fractional exponent is the root. And then when my argument's 1, it's always 0 because we think about 2 to what power equals 0. Any number to the 0 power is 1. And then this last one is no solution. It is an empty set because there is nothing that's going to take a base and make it equal to 0. There is nothing here that would happen. So I have to remember my argument cannot be 0. That's important to remember. Okay, now not all logarithms can evaluate with math facts, so we have to be able to use our calculator. And I have a drawing on here for our Cassia that we use in class. And in Run Matrix, we're going to hit that math button, and then the log AB button comes up. So if it's not told, we normally round these to 4 decimals, unless otherwise stated. So I put this in as I hit math, log AB, put the 3 in, put the 8 in, and this is approximately 1.8928. A couple things that probably should have gone over earlier is a base of 10 is called the common log. So in our calculator, the log button is the common log. That's why we have to bring up log AB. And then the base of E is called the natural log, and that happens to be a French, and so it's the LN button. So this is the log button with no base, and LN for log natural. Okay, now some important skills that we have to remember how to do is how to convert from, how to expand or condense these logarithmic expressions. And these are the rules. So kind of based on our exponent rules, that when I have an argument that I am multiplying, I separate it with addition. And the vice versa of that is if I have two logs that are separated with addition, I multiply their argument together. The next one is if I have the argument that is being divided, I separate it through subtraction. And to condense it, if I'm subtracting two logs, I put their arguments together through division. And then if I have a exponent to my argument, then I would put it in front of the log in multiplication. So if I have a number in front of the log, that means that that is the exponent to the argument. Okay, this first one, I see that I have a log. I have two separate, what I call bases. So that means I'm going to write log twice. And this one has an exponent, so its log's going to have a 2. That is a base 10. So log argument of 3 plus that 2 is the exponent, log argument of x. So since that was multiplication, I expanded it with addition. Okay, this next one, I have, again, I look at these things that tells me I'm going to have two logs written. I'm dividing, so I'm going to connect those logs with subtraction, and that 3 goes in front. So 3 log x minus log 4. And now this last one, it's a natural log. Notice the parentheses. That means x minus 3 is the whole entire argument. I can't break that up. So to expand this, I'm just putting the 2 in front of that natural log, and this stays in parentheses. So that's the only expansion there. Okay, so now we're going to condense. When we condense, I write the log once. And then since I'm adding, I'm going to multiply, and this is going to be x minus 2, x minus 1. I've got to go FOIL that together. Okay, remember that's x minus 2 times x minus 1, and x times x is x squared. X times negative 1 is negative 1x. Negative 2 times x is negative 2x. And negative 2 times negative 1 is positive 2. So this becomes x squared minus 3x plus 2. So that's completely condensed because you simplify it as much as you possibly can, and that is simplified. Okay, this next one, I'm subtracting, so that says that I'm going to have a division. I have a 2 in front, so it goes with that x. So I write log once, and the numerator is x squared. The denominator is 6. That does not simplify anymore, so that I'm done. And then this last one, I'm connecting with subtraction. The 2 goes in front, the 3. So those are exponents. So I write log once, and I have 3 to the second power times x to the third power. Now I'm going to simplify that into 9x cubed. So that would be its final answer. Okay, now on to transformations. The thing to keep in mind, this left and right, this is where my asymptotes come from. So keep that in mind with our transformations. A little bit different, but still the same idea. My A value, let me do shift left and right is inside. Ooh, that's not what I wanted, sorry. My shift left and right is inside. So see inside, and notice it's the opposite. So since I'm adding in my argument, I go left, I'm subtracting, I'll go right. My up and down is this plus K. So I shift up, I'm adding, I'm subtracting. Notice there's no parentheses, so that's outside. And then my stretches and my compressions, my vertical is my A. So this 2 is out front, this half is out front, so stretch is a number greater than 1, vertical compression is less than 1. And then the B value, remember we must factor B. The B value is inside the argument in front of the X. Again, those are opposites, so a horizontal stretch is less than 1, a horizontal compression is greater than 1. And then my reflections are also the A's and B's. So this inside is a B value that's negative, and I would reflect over the X. And this X on the outside is the X inside, the negative inside is the B value. The negative on the outside is the A value, and that's a reflect over the X-axis. Okay, so now let's just put it to use. Let's take a look. This first one, I have a 2 on the outside, so that's a vertical stretch. Then I have a -3 on the inside, so that's right. 3, and then outside I'm adding, that's up 5. Okay, this has a negative on the outside, so that's reflect over X. This has a negative on the inside, that's reflect over Y. And now I have to make sure I factor the B. So remember that's like division, so this becomes positive X and positive 2, because that will help me answer my other. The 2 is a horizontal compression. I already got the reflection. The +2 means I go left 2, and the -6 is down 6. Okay, this last one I'm looking at, again, I see that I have to factor out my B. So 1/2 X plus 14 is what happens there. So now the 1/3 on the outside is a vertical compression. The 1/2 on the inside is a horizontal stretch. The plus 14 is left 14. And those are my transformations again. So they're the same as what we've done before, just a little bit different of location. Okay, now we're gonna look at a graph. This is log x, which remember is base of 10. We're gonna start with that one. And some things to look at over here is when I am graphing these, I'm always using 1, 0, which is right there, which is 1 over to the right of the asymptote, because they're telling me there's a vertical asymptote at 0, so it's 1 to the right. And then so the graph normally is 1, 0, base 1, and then if I want more points, I'd square the base and go up 2. I'd cube the base and go up 3. It's that pattern. So we're going to put on our asymptote at y = 0. This is a base of 10, so 1, 0, and then 10, 1. It comes up, my asymptote hits that point and turns, and that's what the log looks like. The end behavior is as x goes to the left, which it's approaching 0, y goes down, which is negative infinity. As x goes to the right, it's infinity, and it is going up slowly, but it is going up to infinity. Okay, so we're going to start off with something easy. I see log base 5 of x, so my vertical asymptote is at x = 0. So this is, let me change my pen color. This is not been shifted any. So base 1, so I'm sorry, 1, 0. And then base 1, so 1, 2, 3, 4. The base is 5. Up the asymptote and up we go. My domain goes from the asymptote to infinity. The asymptote's at 0. And the range is negative infinity to infinity. So we will have to change these statements. So as x approaches the asymptote, which is at 0, y approaches negative infinity. As x goes to the right, the y is going up. Okay, so we're going to go through and work on this one. I haven't shifted it left or right, so my asymptote's at 0. I have a base of 8, so I'm going to do 1, 0, and the base of 8, 1. But since I have a vertical stretch, I'm going to multiply that by that vertical stretch, which is 2. So now when I go graph this, I'm going to do 1, 0, and then I'm going to count over 8 and up 2, hover next to the asymptote, and turn. So my domain is from the asymptote at 0 to infinity, and my range is negative infinity to infinity, which is always. Now, as x approaches negative infinity, or really as x approaches the asymptote at 0, y is going to negative infinity. As x approaches infinity, y approaches infinity because it's going up. Okay, so this one also hasn't been shifted. It just has reflect over x. So y equals 0 is my asymptote. My base is 6, so I'm going to do 1, 0, base 1. Since I'm reflecting over the x, I'm going to change my y to its opposite. So I'm going to graph 1, 0, and then the base of 6, down 1. So this time it's going to start at the top and move that direction. So my domain is going to be from the asymptote to infinity. My range is bottom to top, so that's always negative infinity to infinity for log. So as x goes to the left, I'm going to the asymptote. So as x goes to 0, y is going to positive infinity. And as x goes to infinity, y is going to go to negative infinity. Okay, so this one is going up 5. So my asymptote stays at x equals 0. And so we're going to move that starting point, and we're going to move that up 5. So that's now my new origin. So I'm going to do my pattern of 1, 0, and then base 1. I'm going to count from that green dot, which is my new origin. So 1, 0, and then base 1, 2, 3, 4, 5, 1, coming up the asymptote and turning. So my domain is asymptote to infinity. My range is negative infinity to infinity. So I go to the left, I'm going to the asymptote at 0, and it's going to negative infinity. And as I go to the right, it's going up, so positive infinity. Okay, this one, I have a vertical asymptote at 1 because I shift to the right 1. And I go down 3. So on that asymptote, I'm going to count down 3. And there's my new origin. So I'm going to use the point 1, 0. And then the base is 8, 1. So from that green dot, 1, 0. back to the green dot, go over 8 and up 1, come up the asymptote and turn. So my domain is asymptote, the asymptote's at 1 this time. At 1 to infinity. My range is always negative infinity to infinity. So as I go to the left, I'm going to the asymptote at 1. The arrow is going down at that point. When I go to the right and I go to positive infinity, it's also going to positive infinity. Okay, this last one, I have a reflection over x. I'm going left 2, so there's where my asymptote is at x equals negative 2. And I go up 1, so that green dot is now my new origin. I'm going to do the points 1, 0, and then the base is 6, 1, but I'm reflecting over y, so I change my x. So I'm going to go 1, 0, and then the base of 1, 2, 3, 4, 5, 6, down 1. So this has the asymptote at the top. Okay. So now my domain is asymptote to infinity, so negative 2 to infinity. My range is bottom to top, which is negative infinity to infinity, because arrow to arrow. So as I go to the left, I'm going to the asymptote at negative 2. My arrow is going up, so positive infinity. And as I go to the right, the arrow is going down, so that goes to negative infinity. And there you go.